Hello and welcome to Elementary STEM with Miss Crosman. Today we're going to be learning about making spinners using snap cubes. This lesson is for the teachers. If you're here looking for the lesson for students, go ahead and click right here. That is the lesson that you want to go to today. Welcome STEM teachers. Today we're going to be talking about a lesson that I like to use with my kindergarten through second grade students. It is called Snap Cube Spinners, and we're going to be doing a little scientific experiment to determine, make a hypothesis, and then do an experiment and track the results to see if a small spinner or a large spinner will spin the longest. And this is a lesson I like to do early in the year, especially with kindergarten, because it is very easy for them to do. They have a lot of success and it's a lot of fun and it's quite busy. And it also gives them a little something to do throughout the whole school year when we have indoor recess because it's rainy or we're in Maine, so sometimes it's just too cold to go outside. So it gives them an idea of something to do with the snap cubes that are in their classroom, usually with the math manipulatives and other things. So the way we do this is I tell the students that we're going to start with a single cube and we're going to look at it and notice that one side sticks out while the rest of them all have indentations where you can attach those little sticking out posts to connect them. We're going to put this is going to be our spinner point. So we're going to put this so it's face up. And then we're going to build legs that connect to the four sides that we can see. Now we want to make all of our legs even length, because if we don't, it's going to be unbalanced and we're not going to get good results, because if you have one leg that's longer than the rest, it's going to drag, and that's not going to be helpful when you're trying to see how long it spins. So once they've built their four legs, they're going to insert those on the four sides of their snap cube. So we're going to press these in just like this. Now at this point, they could be done. I tell them to flip it over, give it a test, see how it works. But I also talk about the fact that I like to have a handle, so I make a handle for mine. Some of your kids, especially younger ones who may not have the best dexterity, may need to use a handle as well. Once we have one spinner built, we're going to set that aside. Then the students are going to build their second spinner. So this is mine. Looks like this. We start the same way. What I usually do is have one that's taken apart so I can show them the pieces that go into it. I've been doing this lesson for about 3 years, and I just find that if you have a model to show them, with this particular lesson, they're not going to try and imitate my exact model. They're going to put their own expression into it. So it's okay to show them how to build one. So again, we start with that centerpiece, and we start by building four legs that are all the same length. Each one of these is 7 cubes long. I try and encourage that your small spinner and your large spinner are very visually different, because you'll sometimes have kids build two that are the exact same size or that may only be 1 cube longer in the legs. Encourage almost double the distance to see really what happens when you do have a difference in length. So now, here's the build. We're going to put that 1 cube in the middle. Again, pointy side up helps, because if we don't tell them to put it pointy side up, what they have a tendency to do is flip it over on their side and build it like this. They get the whole thing built and they've got no spinning surface. So this is why I ask them to start by putting this up, point your legs in, press them in, and then flip your spinner over, add the handle. Now, I also encourage the use of tails. We've got legs and these are now tails. They all have to be identical. They all have to have the same number of pieces in them. But these just kind of make it look really cool, and they add extra weight as well. And the extra weight is going to be what's going to help show them which one is going to spin the longest. Now, once they have both of them done, there's a couple different ways you can test. If you have stopwatches or iPads that you can use the stopwatch feature in your classroom, I highly recommend that they partner up with somebody and one person's the timer and one person's the spinner. And the timer says, on your mark, get set, go. And when they say go, both the person running the timer hits the start button on the stopwatch and the person spinning starts it spinning. Because you're going to have to do many trials of this, because these will spin off the table. They will be spun so vigorously that the legs go flying. You will be finding snap cubes all over the floor of your classroom for a couple days. So just prepare for it. So it's going to take several times for them doing it. So they're not going to just be able to stand at their table and spin both at the same time. They're going to run into each other. It doesn't always work. You can do it that way. I have a lot of students who do it that way, but they're going to have to do about 10 trials before they get the results. So I like to have kids time it, or they can partner up with somebody and at the same time one spins one on one end of the table and one spins the other on the other end of the table so they don't collide. However, this means if there's anybody else working at the table, it can get in the way of other things going on. And we have carpet in my room, so we can't really spin these on the floor. We've really got to spin them on the hard tables. Another option that you can do is have each kid time themselves. They hit the start button with their left hand as they're spinning it with their right hand if they're right-handed, vice versa if they're left-handed, so that they can spin both equally. Because what I also tend to notice is whatever kid's dominant hand is, sometimes that skews the results because they will spin it harder with their right hand than their left hand if they're right-handed, and again, vice versa if they're left-handed. So it helps to partner them up at this point. I do like to have, for this particular project, kids build completely separately, but then partner up with somebody and both help each other test out their results. Now, I like to have students track results because this is, we really like to talk a lot in my STEM class about data and collecting data. My son loves the show Mythbusters, and I love this quote that the difference between science and messing around is whether or not you tracked your data. So just spinning it is messing around, but actually measuring how long it spun and also putting something on a graph somewhere is tracking data, and then we're doing an experiment. What I like to do with my younger students is I have these magnetic push pins, and I actually love these. I bought them for both my classrooms and my house because they work so well in so many different ways. So I did tag them below. They're just an Amazon item. I tagged them below, not too expensive, and they work great for me for doing experiments like this because I give each kid a magnet and I draw a chart on the board. And it's a visual chart because with kindergarten they might not be able to read the words. So I write big on one side, small on the other, but then I draw a small snap cube and I draw a big snap cube spinner. And then when they have conducted their experiment, they take their magnet and they put it on the side to show which one of their spinners went the longest. And then at the end of class, we can get together and we can look at that data and we can see if there was a tendency for one to do better than the other. We can also look at, sometimes there isn't an overwhelming majority, and we can say, you know, why do you think that that was? And kids will say different things like, well, every time I spun my big one, the leg went flying off it. And we also talk about the idea that sometimes one kid's version of a big one is really somebody else's version of a small one. Because if somebody built something half this size, but it was slightly bigger than this, then there's going to be a noticeable difference. Or if their small one was a little smaller. So we talk about that too, and we can bring in scientific variables, stuff like that. So it's a great lesson because it covers a lot of really basic concepts that the kids do need to know. So this is a fun activity. I have created a video that's just for students if they happen to be doing this on their own during distance learning, if your schools have closed down. There is a link to that video as well, so this is something that you could send the supplies home for, and you could put a little QR code right on the baggie and send the kids to this lesson. I'm going to link it right up here, so look for it if that is the one that you might want to assign to students. All right, enjoy this one. We have fun with it every year. On your mark, get set, spin.
Oh,
yeah, start over.
Redo.
Okay, on your mark, get set, go. So my son Justin, when I asked him to help me out with this experiment, mentioned that when he did this back in second grade, that he had an additional piece at the bottom, and that for larger ones that had a tendency to help it go longer. So we're going to do a second round test. So ready, Justin?
Yep.
All right, on your mark, get set. I think it does go a little longer with it that way.